Network basics. What is a network? When two or more systems or electronic devices are connected or linked together, it forms a network. Consider this network. This network has three LANs, namely ETH0, ETH1, and ETH2, connected to the internet via a router and a modem. Notice that there are different devices linked together in this network. But have you ever wondered how these communicate with each other? Imagine an Apple computer and Windows-based computer want to communicate with each other. It is like French and German communicating with each other. Do you think there is a possibility for good communication? Yes, if there exists a common language known to both. Say for example, if both knew English, it would facilitate the communication between them. In the same way, in order to accomplish a smooth communication between systems and networks of different architectures, OSI, Open System Interconnection Model, was introduced. OSI defines a layered framework for the travel of data from one system or network to another. It has 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Each layer in this model performs its respective tasks by communicating with the layers above and below it. Take for example that two systems, say a Windows and a Mac, communicate via a chat application wherein the Windows system is the sender and the Mac system is the receiver. Suppose if the Windows machine sends a welcome note, such as "Hi Mac," via this application, the data travels via these 7 layers and reaches the destination, after being operated upon by the underlying protocols. But what happens when the data travels through these layers? Let us take a look at the user interface that allows the Windows system to chat with his peer. This is where the application layer plays its role, controlling the application that allows it to communicate, along with the UI's look and feel. The application can also be a browser, a file sharing program, or something else. As mentioned, this layer has its own protocols, such as HTTP, HTTPS for web applications, FTP for file sharing, and SMTP and POP3 for the sending and receiving of emails respectively. In this case, the application is the chat client. Once the data, that is, "Hi Mac," is typed in and sent, the control gets transferred to the presentation layer. The presentation layer checks for the OS compatibility, encryption and compression of the data before passing it on to the next layer, which is the session layer. The session layer is the one that provides the mechanism to manage sessions, that is, the active time of a user on a particular web application. The session ID is assigned for the current session, and the data now gets passed on to the transport layer. Study on the OSI model reveals that the top 3 layers are called the web interface, where one can see the data being passed on without adding any specific headers. The 3 layers at the bottom are called the network interface. The transport layer is the one that acts as a mediator to shoot the data out as well as receive the data in. As the name says, this layer is responsible for the transmission of the data. It converts the data into segments of a limited size with a segment number for easy reassembling at the other end, along with a header called the transport layer header, which is either based on TCP or UDP. Let us take a glimpse at these protocols. TCP, Transmission Control Protocol, is a connection-oriented protocol, which when used sends a probe using this TCP header. It consists of source port. It is through this port the client gets connected to the server. Usually the source port is an ephemeral port, which is nothing but a short-lived transport port assigned automatically from a predefined range that is always greater than 1024. The destination port is a well-known port on the server whose range falls between 0 and 1023. Sequence number, acknowledgement number, data offset, window size, checksum, erg pointer, and 6 other flags. To ensure a connection-oriented communication, it uses a three-way handshake wherein these 6 flags play a major role. A flag is a 1-bit Boolean field to mark the occurrence of an event. Let us get to know how these flags are helpful in a communication. When host A needs to send data to host B, connection initiation is done by setting up the synchronization, shortly SYN, flag in the probe. When host B receives this probe, it sends a reply probe with reset flag when it is not available for communication. Otherwise, it sends a reply probe with synchronization acknowledgement, shortly SYN-ACK. On receiving this, host A sends a probe with acknowledgement, shortly ACK, to impart that the connection is established, and then it starts sending the data. This is called a three-way handshake, and this process of connection establishment makes TCP a connection-oriented protocol. When the data transmission is done, the sender can send a probe with finish, shortly FIN flag, which closes the connection. Apart from this, while in data transmission, a push flag can be set along with the data that would instruct the system to send data immediately. Or an urgent flag can be set, which will inform the receiving station that certain data within a segment is urgent and prioritize the delivery of this data. Next comes the user datagram protocol, which when used consists of this header. One may notice that the header consists of only the source and destination addresses along with the length of the data, its checksum and the data to be sent. Since it does not wait for any acknowledgement for establishing a connection and for transmission of data, it is called a connectionless protocol. This protocol is best when used for query response or streaming. TCP is a reliable protocol when compared to that of the UDP, since it establishes a connection using the three-way handshake, ensuring a connection-oriented data transmission, while UDP simply transmits the data, terming itself to be a connectionless protocol. In terms of speed, UDP is faster than that of TCP, since this one does not wait until the recipient acknowledges any data transmission. Once the headers are appended, this layer concentrates on handing over the data to the appropriate application process on the host computers, wherein the control is transferred to network layer. Network layer is responsible for the host-to-host delivery of data segments from the transport layer. This layer adds a header called the IP header, consisting of the source and destination IP address, which is similar to that of putting a letter into an envelope with a from and to address, thus converting the segment of data into a packet of data. So, what is an IP address? Similar to that of a physical mailing address, Internet Protocol address is a logical address that uniquely identifies each and every system connected on a network. At this point, it is important to know whether the communication is going to happen between systems inside a network, that is baseband communication, or out of the network, that is broadband communication. The routing of packets from the network layer is taken care by the network layer device called a router. A router is a device that connects two different networks. It works based on IP addresses and routes the data packets along the network on deciding the next point to which the packets need to be forwarded. It acts more or less like a dispatcher. To put in simpler terms, the router acts like a traffic cop who forwards the traffic to destined places either from and to the internet or within the same network. Thus, the data is now transmitted to the next layer, the data link layer. This layer is further divided into two sub-layers, Logical Link Control, or LLC, and the Media Access Control, or MAC. LLC ensures reliable data transmission by appending sequence number to each transmitted packet before sending and sends back an acknowledgement for each received packet. When the MAC layer receives the data from LLC, it interacts with the physical layer below. This is responsible for creation of frames from the packets it received from the network layer, on appending a frame header and frame trailer. Switch and hub come into play at this layer. Unlike the router, the switch and hub cannot connect two different networks. However, a layer 3 switch can act like a router. Switch is a device that works based on the MAC address That is the unique number assigned to each and every system in their network interface card. This device ensures point-to-point delivery of data. A hub is a device similar to that of the switch, wherein the difference lies in the delivery of the data. A switch is a unicast device that concentrates on point-to-point delivery, but a hub is a broadcast device, and the data reaching the hub is broadcasted to all the other devices connected to it. Finally, the data reaches the physical layer, wherein the frame is converted either as a digital or analog signal, that is bit stream, and gets passed on via the wires, if the network is a wired network, or via air, if the network is a wireless one. Basically, this is where the network hardware seen facilitating the functions of the data link layer and the network layer get into action. As seen already, when two or more systems or electronic devices are connected or linked together, it forms a network, and these connections are made possible via connection cables. An Ethernet cable is one of the most popular forms of network cable used on wired networks. Ethernet cables connect devices on local area networks such as PCs, routers and switches. The physical layer thus forms the fundamental for all the communication, and it is revealed that 95% of network-related communication issues arise at the physical layer. Once the physical route to deliver the bit stream, either as analog signals in a broadband communication or digital signals in a baseband communication, is identified, the data is routed to its destination. Finally, the receiver gets the data in bitstream and the corresponding headers for all the layers are verified, and the application layer now displays the message to the MAC system. This is how communication happens between systems on a network. Having seen how communication happens between systems, one might have noticed that certain parts of the network here have not been touched upon at all. Let us get into knowing these things. Did you see that the router is allowing traffic that seems to be legitimate, while it discards the illegitimate one? This is because a firewall is configured at this point. What is a firewall? A firewall is a system that filters the incoming and outgoing traffic to avert unauthorized access to or from a private network. All messages entering or leaving the intranet pass through the firewall, which examines each message and blocks those that do not meet the specified security criteria. As such, a firewall can be described as stateful and stateless. When a firewall is termed to be stateful, it is capable of monitoring the entire content of the data packets, that is the traffic stream passing through it, and distinguish the legitimate packets that belong to different types of connections. When a firewall is termed to be stateless, it is capable of capturing only the source and destination IP. It does not monitor the entire traffic stream and does filtration based on the source and destination IPs alone. Did you notice the IP address of the router and the systems in the LANs are different? Why is it so? Just imagine a tech giant like Microsoft, which holds n number of systems to run their processes. If each and every system is assigned with a unique IP, the range of IPs available will surely be exhausted at some point in time. To overcome this issue, the ICANN, or Internet Corporation for Assigned Names and Numbers, a non-profit organization, takes care of the coordination and maintenance of the databases of the unique identifiers, that is, IP addresses, and came up with the concept of subnetting. What is subnetting? The process of dividing an IP network into subdivisions is called subnetting. Computers belonging to a subnetwork have a common group of the most significant bits in their IP addresses. The addresses used for subnetting fall under the following series: 10.x.x.x series, 172.16.0.0 to 172.31.255.255, and 192.168.x.x series. When these multiple subnets with a common prefix are combined to form a large network, it is called supernetting. The IP address assigned at the router point is the public IP, and this entire network connected to this router is identified with this IP by the other systems on the internet. The IP address of each and every system inside the network is its private IP. This IP is not known outside the network. So how is it ensured that the data packets to and from the public network are delivered properly from and to the system in the private network? Here comes the role of the router. The router is configured to support a concept called NATing. NAT, Network Address Translation. The process of translating a private IP into a public IP is called NATing. When there is no large network and you just want to connect a router to two different systems in your home network, the concept of patting comes into picture. Port address translation is the process of assigning port numbers to the internal IP address of the machines connecting to the internet. This now facilitates the data transmission. Although all these implementations seem to be effective, the study on the growth of internet devices in recent times shows that the time where one internet device was used by at least 4 to 5 members has gone, and each and every individual now owns at least 2 to 5 internet devices, which eat up the available public IPs. This clearly shows that the number of machines connected to the internet exceeds the number of people alive on the earth. That's where the introduction of IPv6 came into play, which is of 128 bits in length and ranging between the following address space. This is how a network is and how the systems here communicate.